तो चलने से कहां मिलते हैं तमन्नाओं के शहर, चलना भी जरूरी है मंजिल पाने के लिए। हेलो एवरीवन, माई सेल्फ चंद्रशेखर वेलकमिंग यू ऑल टू दिस ब्यूटिफुल सेशन ऑफ thermal engineering. In this session, we are going to discuss the previous GATE 5-year question. So today's session is all about the exam 2022 and 2023. All right. So please do let me know if I am audible and visible to everyone so that we can start the session. Can you guys hear me? So we have already completed the questions from 2019, first part, second part, the questions from 2020, and the third part, the questions from 2021. And today we will be discussing the GATE previous year question for the year 2022 and 2023. Am I audible and visible to everyone? Can you guys hear me? आवाज आ रही है मेरी आप लोगों को? Quickly do let me know if you can hear me, those who are watching me live. So those who are meeting me for the very first time, this is my short, sweet, simple introduction. I am mechanical engineering graduate from IIT Delhi. Hi Nitesh, good evening, welcome. All right, good. Are you all ready to do the calculation for the previous year GATE paper? So I have also cleared the engineering services examination, which is conducted by UPSC, worked in Steel Authority of India Limited for a couple of years, and from the last 10 years, I am completely into teaching, guiding the students who are preparing for various competitive examinations like GATE, ESE, PSUs, and others. I am quite comfortable in these mentioned subjects of mechanical engineering, fluid mechanics, heat transfer, thermal, and industrial engineering, right? You can always connect with me through the mail ID which is there at the top of the screen, and you can join me on the Telegram if you are not part of my Telegram channel yet. That is Mechanical by Chandrasekhar. Please do join me on the Telegram because around 1500 students are already there. And once you become part of the Telegram channel, these many benefits you will be able to get to improve your preparation journey, to make your preparation more result oriented. All right, this is the link to join me on the Telegram. I hope you guys are already part of my Telegram channel. So you guys are watching me live through the series, beautiful series on the students' demand. We started this last 5-year GATE PYQ series for civil and mechanical engineers, and today is the last session for thermal. And then after the thermal, you will be having a session on mechanics taken by Suraj sir. You will be having some sessions on production. Let me show you the complete schedule for this series. Are you able to see it? Production, then again I will have the sessions, couple of sessions for heat transfer, right? So this is what is the next few days schedule for the last 5-year question practice. So without wasting much of your time, let us start the sessions. Shall we start? Are you all ready? क्या आप लोग तैयार हैं? Please let me know through the comment section. If your answer is yes, then give me the answer to this question, question number 1, which was asked in GATE 2022 in set 1. It does not matter whether it was asked in set 1 or set 2. So I will discuss all the questions based on thermal engineering. What is the answer to this question, Arnab? Nitesh, quickly, बताइए, what do you think? The Clausius inequality, very beautiful inequality given by the Clausius, cyclic integration of del Q by T. What is Clausius inequality? Cyclic integration of del Q by T can be less than or equal to 0. If it is less than 0, then the cycle will be irreversible. It is the cyclic integration, and if it is equal to 0, then the cycle will be reversible. And if it is greater than 0, If it is greater than 0, what does that mean? The cycle is impossible. So it is not for a process. It is not at all for a process. It is for a cycle. What is the correct answer? No, Arnav. Clausius inequality does not define for a process. No. It is not, Nitesh. Not correct. It is defined for the cycle because it is about the cyclic integration of del Q by T. So it is for any cycle. Option B is the right answer to this one, isn't it? Got it? It is not for a process. It is defined for a cycle. Very simple question. The next question was asked in GATE 2022. The next question, a polytropic process which is carried out from an initial pressure of 110 kilopascal and initial volume of 5 meter cube to a final volume of V2 is given. The polytropic index N is 1.2. The absolute value of the work done during the process in kilojoule is. What is the work done? So those who have joined me lately, I welcome you all from the bottom of my heart. Please sit back, relax and enjoy this beautiful session, and do not forget to like, share and subscribe our BYJU'S YouTube channel. So the work done in a polytropic process, the simple formula P1 V1 minus P2 V2 upon N minus 1. Do you remember? P1 is known, V1 is known, V2 is known, N is known. The problem is about P2. So for a polytropic process, can we say P2 by P1 is equal to V1 by V2 to the power N? For a polytropic process, can we say P2 by P1 is equal to V1 to the power V1 by V2 to the power N? So what is P2? That is P1 110 kilopascal. What is V1 by V2? 5 upon 2.5, that is 2 to the power 1 by 1.2. What is the value of P2? First of all, let me know the value of P2. Who will be giving me the value of P2? Keep your pen, notebook and calculator. What is the value of P2? And do let me know if my value is matching with yours or not. 252.71. Very nice. 252.71 kilopascal. Once you get the value of P2, then you can easily find the work done. If the answer should be in kilojoule, keep the pressure in kilopascal. Do not get confused with the units. Always become comfortable. You should be comfortable with the units so that you can play with them. So what is P1? 110 into what is V1? 5 minus what is P2? 252.71 into what is V2? That is 2.5 upon N minus 1, that is 1.2 minus 1. What will be the answer? What is the work done in a polytropic process? Who will get me the answer for this? Quickly, everyone, get me the answer. You will be getting negative. Are you getting negative? 408.9 kilojoule. Why we are getting it is kilojoule? Because the pressure are taken in kilopascal, isn't it? 408.9 kilojoule will be the right answer. 408.9 will be the correct answer to the question number 2. Let us move to the next one. Yes, Arnab, Nitesh, well done. Good. Please do share this session to all your friends so that others can also join and get benefited. The next question. In a steam power plant based on Rankine cycle, okay, steam is initially expended in a high pressure turbine. The question is not from the power plant as such. It is from the second law of thermodynamics, or it is from the first law and second law. It is from the cyclic device. The steam is initially expended in a high pressure turbine. The steam is then reheated in a reheater. All right, there are multi-stage expansion, then finally expanded in a low pressure turbine. The expansion work in the high pressure turbine is 400. Can we say WT1 is 400 kilojoule per kg? And in the low pressure turbine, WT1, T2, the second turbine, the expansion work is 850 kilojoule per kg. Whereas the pump work, WP, the pump work input is 15 kilojoule per kg. So what is W net? We can easily find out W net, WT1 plus WT2 minus WP. That is the net work output. If the cycle efficiency is 32%, the heat rejected in the condenser is, what does that mean? We need to find out Q2. So W net will be equal to 400 plus 850 minus 15 kilojoule per kg. What is W net? Can you find out the value of W net? What is the value of W net? 1250 minus 15. 1250 minus 15. 1235. So the thermal efficiency is 0.32. That is equal to W net upon Q1, heat supplied. So we can find out Q1 is equal to W net upon 0.32. W net is 1235 upon 0.32. So Q1 will come out to be 3859. Yes, very nice. Are you getting Q1 as 3859.37 kilojoule per kg or not? The question is not about heat input. The question is actually about heat output to the sink. So as we know that Q2 must be equal to Q1 minus W net. Q2 will be equal to Q1 minus W net. So it will be 3859.37 minus 1235. That will give you the final answer. क्या बता रहे हैं नितेश? Q2 नहीं, subtract होगा ना. Are you adding it? So you need to subtract. If we draw, this is Q1 heat added, this is Q2 heat rejected, this is the net work output. This is, so from the first law of thermodynamics, Q1 is equal to Q2 plus W net, or we can say Q2 is equal to Q1 minus W net. You need to subtract it. Are you getting 2624.3? Are you guys getting 2624.3? Give me yes, give me cheer. 2624.3. 2624.3 kilojoule per kg. Simple question from the cyclic device, work producing cyclic device, whether it is Rankine cycle or Brayton cycle or Otto cycle. How does it really matters? How does it matter, right? Shall we move to the next one? This question was beautiful, which was asked in, the question is from the critical flow condition in a nozzle. It was MSQ asked in 2022. The figure shows a purely convergent nozzle which study in viscid compressible flow. It is from the critical flow condition in nozzle. Do you know what is critical flow condition? Do you know what is critical condition or choked condition? Critical flow condition is also called as choked condition. Are you guys aware about the choked condition? The figure shows a purely convergent nozzle with a steady inviscid compressible flow of an ideal gas with constant thermophysical properties operating under choked condition. What is the choked condition? When the back pressure becomes equal to the critical pressure. When the back pressure becomes equal to the critical pressure, then the mass flow rate reaches the maximum value. Mass flow rate becomes the maximum. And the critical pressure is the pressure. What is the critical pressure? Critical pressure is the pressure for which the velocity of the fluid becomes velocity of pressure wave. That is called as critical pressure. The velocity of the fluid becomes equal to velocity of the sound. So Mach number is equal to 1. This happens at the throat. So for the critical flow condition, Mach number will be equal to 1 and the mass flow rate will be maximum and the back pressure will become equal to critical pressure. These are the condition for, these are the properties or the characteristic of choked condition, right? The exit plane shown in the figure is located within the nozzle. If the inlet pressure P0 is increased, if P0 increases, keeping the back pressure unchanged, which one of the following statements is or are true? The mass flow rate through the nozzle will remain unchanged. That is not correct. The Mach number at the exit plane of the nozzle will remain unchanged at unity. B is correct. The Mach number will become more than unity. At choke condition, Mach number will become equal to 1 at the exit or at the throat. So what about the mass flow rate? Mass flow rate is given by, per unit area is given by under root of gamma by R into P naught by under root T naught into, we can say, 1 upon gamma plus 1 by 2 to the power gamma plus 1 upon twice of gamma minus 1. This is the expression. So mass flow rate will be dependent on P naught. As P naught increases, then the mass flow rate also increases. B and C will be the right answer for this one. Option B and C. B and C both will be correct. B and C both will be correct. The next question from 2023. The next question is from 2023. Can you solve the next one? Can you guys solve the next one? A heat engine extracts heat QH from a thermal energy reservoir at a temperature of 1000 Kelvin, that is T1, and rejects heat QL to a thermal reservoir at a temperature of 100 Kelvin. This is T2. While producing work, which one of the following combinations of QH, QL and W given is allowed? First law says Q1 should be equal to Q2 plus W. That is the first law of thermodynamics. If we talk about an engine, Q1 is heat added, Q2 is heat rejected, and the work is W is the work output. So from the first law of thermodynamics, for any system, the net heat transfer is equal to net work transfer, or energy entering is equal to energy leaving. If you talk about option A, QL plus W is equal to 1500, but QH is 2000. A violates first law. A violates first law. If we see D, QL is equal to 60 and W is equal to 5500, it means it is greater than 6000. D violates first law. So B and C are the probable candidates. So if the efficiency of this cycle or heat engine is less than Carnot efficiency, then only the cycle will be possible. So if I ask you what will be the Carnot efficiency? Carnot efficiency is the maximum efficiency when the cycle is completely reversible, T2 by T1. What is Carnot efficiency? 1 minus what is T2? 100 upon 1000. So 1 minus 1 by 10. That is 9 by 10. 0.9. Carnot efficiency is 0.9. If we talk about B, what is the efficiency of B? W net 1250 upon Q in 2000. What is the value? What is the thermal efficiency for B? W net upon heat supplied. What is the efficiency for B? Are you getting 0.625? 0.625, yes. And what about C? For C, the thermal efficiency is given by W5500 upon 6000. Isn't it 0.916? So C cannot be correct because the efficiency should always be less than the Carnot efficiency. So only B can be the right answer. It is only B which can be correct. I hope this is clear. Right? Shall we proceed further? If anybody is having any doubt, you are most welcome to ask me. So there is an important workshop conducted by Rakesh Talreja sir on 20th of June at 7:30 p.m. So this is the free workshop for all the GATE aspirants, and he will be discussing about the strategy to clear the GATE examination within 8 months. So this is going to be very beneficial workshop. Do register yourself for this workshop and ask your friends also to register for it. All right. Make a note of it. It is on 20th of June at 7:30. The next question again asked in 2023. Which one of the following statements is false? The question was asked for 2 marks. It is MCQ, but 2 marks? I don't know whether it was asked for 2 marks or 1 mark. Which one of the following statements is false? You need to find out the false statement. For an ideal gas, enthalpy is independent of pressure. That is true. H is a function of temperature only. A is true. So if A is true, can we cross it out? A cannot be the answer. For a real gas going through an adiabatic reversible process, the process equation is given by PV to the power gamma is constant. This is given for ideal gas. This expression is developed only for ideal gas. PV to the power gamma is equal to constant is not applicable to the real gas. So we can say B is the false statement. Are you getting it? For an ideal gas undergoing a reversible polytropic process, PV to the power 1.5 is equal to constant. The equation connecting the pressure, volume and temperature of the gas at any point along the process. This is the ideal gas equation. Yes, PV is equal to MRT. This is true. So that is why the statement is not false. See, that if you are talking about the right option for the question, that is B. If you are telling me that the true statements and false statement, A is true statement, C is true statement, and D for any real gas behaves as an ideal gas at sufficiently low pressure and sufficiently high temperature. The real gas behaves as an ideal gas at very low density. At a very low density. When the density becomes low, the density becomes low when the pressure is low or the temperature is high. So statement D is a true statement. That is why it is not the answer. B will be the correct answer to this one. Getting it or not? The real gas behaves as an ideal gas at sufficiently low pressure and or sufficiently high temperature. So B will be the right answer. Let us move to the next one. MCQ for 2 marks asked in 2023. Simple question. Consider a fully adiabatic. What is the meaning of fully adiabatic? Q is equal to 0. There is no heat transfer. Piston cylinder arrangement as shown in figure. This is the piston cylinder arrangement. The piston is massless and the cross-sectional area of the cylinder is A. The fluid inside the cylinder is air considered as a perfect gas with gamma being the ratio of specific heats at constant pressure to specific heat at constant volume. What is the answer to this question? The piston is initially located at a position L1. The initial pressure of air inside the cylinder P1 is very, very large compared to the atmospheric pressure. The stop S1 is instantaneously removed and the piston moves to the position L2 where the equilibrium pressure of air inside the cylinder is P2. So P1 and P2 are very large. What is the work done by the piston on the atmosphere during this process? So atmosphere is exerting a force like this P0. Atmospheric pressure will exert a force like this P0. To overcome the atmospheric force, the work is done by the gas. So can we say the work done is equal to integration of PdV and or it is the external pressure. The work is done against the outside pressure. It is the work done against the atmosphere. So P external into dV and the external pressure is constant. So can we say W is equal to P naught into V2 minus V1, isn't it? What is V2? So we can say P naught into area into L2 minus L1. That is the work done against the atmospheric air. That is the work done. That is the work done by the air against the atmospheric pressure. So the correct answer is option number B. The right answer is B. Yes or no? The right answer is option B. Right? Let us move to the next one. Consider a mixture of two ideal gases X and Y with molar mass. This was asked in 2023. Consider a mixture of two ideal gases X and Y with molar masses. Molar mass is molecular weight. Either we call it as molar mass or we can call it as molecular weight. And what is the unit of molecular weight? Gram per mole or kg per kilomole. So the molecular weight of X is equal to 10 kg per kilomole and the molecular weight of Y is 20 kg per kilomole. These are the molecular weight or molar masses respectively in a container. The total pressure in the container is 1000 kilopascal. It is the mixture, so total pressure of the mixture is equal to 100 kilopascal. The total volume of the container, volume of the mixture is equal to 10 meter cube, isn't it? And the temperature of the content of the container is 300 Kelvin. Temperature of the mixture is equal to 300 Kelvin. If the mass of X in the container is 2 kg, mx 2 kg, then the mass of Y is how much? That is the question. Can you find out my? How to do it? They are ideal gases. These are the ideal gases. So can we write the ideal gas equation? Can we write the ideal gas equation? PV is equal to mRT. P mix, V mix is equal to M mix into R mix into T mix. Or can we write it as PV is equal to N into R bar. R bar is universal constant into T. N mix into R bar into T mix. So temperature of the mixture is given. R bar we all know. Universal gas constant is already mentioned. Joule per kilomole Kelvin 8314. And pressure of mixture is given. We need to write N for mixture, that is equal to Nx plus Ny. The number of moles of the mixture is Nx plus Ny. So what is Nx plus Ny? Can we write it as pressure of the mixture is 100 kilopascal. Pressure of the mixture is 100 kilopascal. Volume of the mixture is 10 meter cube. Volume of the mixture is 10 meter cube is equal to N 1 plus M. So mass of A, mx, that is 2 upon 10, 2 by 10 plus my is unknown, then divide by molecular weight. What is the number of moles? Mass upon molecular weight is 20 into, they will be in kilogram, isn't it? Or kilomole. So then R bar, can we write it as 8.314 because we want in kilojoule, because it makes the kilojoule. Left hand side is kilojoule. 100 kilopascal into 10 meter cube is kilojoule into temperature of the mixture is 300. Can you find out the unknown my? Can you find out the value of unknown my? Yes, your turn now. Yes, Nitesh, well done. So we can say these two will get 0 will get cancelled out with this 2. So we can find out the value of M. So it will be My. Solve for My. My should come out to be 4.02 kg. It should be around 4.02 kg. Do not commit mistake in the units. Don't take 8314. If you are taking 8314, then do not forget to take pressure as 100 into 10 to the power 3. If you are taking 8314, do not forget to take pressure of the mixture as 100 into 10 to the power 3. Pressure in kilopascal multiplied by volume in meter cube will become kilojoule. So because it is in joule, then we need to convert it into kilojoule, then we will get the answer. The next question, again from the compressible flow. Lot of questions were asked from the compressible flow in 2023. Question number 9. We are having around 15 questions. 15 questions in total. Consider an isentropic flow of air. Specific heat ratio is 1.4, that is gamma. through a duct as shown in figure. The variation in the flow across the cross section are negligible. The flow conditions at location 1 are given by this: pressure, density, velocity. The duct cross sectional area at section 2 is given by A2 is twice of A1. A1 denotes the cross sectional area at 1. Which one of the following given statements about the velocity U2 and pressure P2 at location 2 is true? We need to find out the Mach number at location 1. What is the Mach number at location 1? That is velocity at upon C1. We can say U1 upon under root of gamma R T1, isn't it? So can you find out the Mach number? Mach number at 1. What is U1? U1 is given as 400. And how to find out R? R is equal to P is equal to rho RT. So R is equal to P by rho into T. R is equal to P by rho into T. So we can say 400 upon under root of what is gamma? Gamma is 1.4 into P1 upon rho 1 into T1 into, can you find out the value of what is T1? Do we require T1? T1 getting cancelled. So can you find out the Mach number at 1? 400 divided by 1.4 into pressure at 1 is 100 kilopascal. So 100 into 10 to the power 3 divided by density at 1 is 1.2 kg per meter cube. What is the value of Mach number? What is the Mach number? Can you find out the value of Mach number at 1? Are you guys getting it as, how much is it? It is. Are you guys getting as Mach number as 1.17? Are you guys getting it as 1.17? Because it is greater than 1. Because it is greater than 1, then it is supersonic condition. Because it is greater than 1, it means supersonic condition. And in case of supersonic flow, condition, the diverging section will become a nozzle. The diverging section will be a nozzle. In case of supersonic flow condition, if the Mach number is greater than 1, then the divergent section, this is location 2, is a nozzle, and in case of a nozzle, velocity increases and pressure decreases. So U2 is greater than U1, U2 is greater than U1, and P2 will be less than P1. Do you understand it? The diverging section will become a nozzle, and nozzle always increases the velocity at the cost of pressure. So U2 will be greater than U1, U2 will be greater than U1, and P2 will be less than P1. Option C will be the right answer for this one. Option C is correct. This was question number 9. Let us move to question number 10, asked in 2022. An engine running on an air standard Otto cycle, constant volume cycle, has a displacement volume. What is the displacement volume? If we draw the Otto cycle on PV curve, it is something like this. 1 to 2 is isentropic compression, 2 to 3 is constant volume heat addition, and 3 to 4 is isentropic expansion, and 4 to 1 is constant volume heat rejection. Isn't it? This is the Otto cycle. And what is the displacement volume? Do you know displacement volume is this? This is V1, this is V2. So displacement volume V1 minus V2 is given as 250 centimeter cube, and the clearance volume is this VC, and this is VS, swept volume or displacement volume. So V2 is given as 35.7 centimeter cube. These are the values given. The pressure and temperature at the beginning of compression process are 100 kilopascal. That is P1, 100 kilopascal, and T1, 300 Kelvin respectively. Heat transfer during constant volume heat addition process. This is QS per kg. The specific heat at constant volume is 0.718, right? And the rate of specific heat at constant pressure and constant volume is 1.4. Assume the specific heat to remain constant during the cycle. The maximum pressure in the cycle. Do you understand? P3 is the maximum pressure. We need to find out the maximum pressure. But before that, can we find out the compression ratio? Can we find out the compression ratio? What is compression ratio? R is equal to V1 by V2. Can we find it? So can we say V1 minus V2 is equal to 250 divided by V2, which is equal to how much? 35.7. So can we say V1 by V2 minus 1? So V1 by V2 minus 1 is equal to 250 by 35.7. This is the compression ratio. What is the value of R? What is the compression ratio? R. Will it come out to be? Will it come out to be 8? 35.7, 250 divided by 35.7 is 7. 250 divided by 35.7 is nothing but 7. So 7 plus 1, 8. Compression ratio will be 8. Now, we need to find out P3 from 2 to 3. For the process 2 to 3 is constant volume. If constant volume, we can say P is directly proportional to T. So can we say P3 is upon P2 is equal to T3 upon T2. We can find out the value of P3 from here. But for that, what we require is, we require P2, we do not know. We require T2, we do not know. We require T3, we do not know. Right? So starting with the initial step 1 to 2 is isentropic. Process 1 to 2 is isentropic. Then can we say P2 by P1 is equal to V1 by V2 to the power n or gamma? And what is V1 by V2? So we can say P2 is equal to P1 into R to the power 1.4. Can you find out the value of P2 from here? P1 is given as 100 kilopascal into R is 8 to the power 1.4. What is the value of P2? Can you find out the value of P2? Can you find out the value of P2? 1837.9. Are you getting P2? And similarly, we can say T2 by T1 is equal to V1 by V2 to the power gamma minus 1. So from here we can find out T2. T1 is given as 300 Kelvin. 300 into 8 to the power 0.4. So T2 will come out to be, can you find out P2 and T2? T2 should come out to be 689.22. Right? T2 will be 689.22. So once we get P2 and T2, then using the heat addition, 2 to 3 is heat addition, constant volume heat addition, as 2 to 3, constant volume heat addition. So we can say QS is equal to CV into T3 minus T2. What is QS? QS is given as, how much is heat addition? 800 kilojoule. And CV is given as 0.718. 800 is equal to 0.718 into T3 minus T2. T2 is already calculated as 689.22. 689.22. So using this we will get T3. The value of T3 should come out to be, the value of T3 should be equal to 1803.42. Are you guys getting it or not? If you are not getting the values, please do let me know. Once we get all the values put in equation number 1, so P3 is equal to P2 into T3 by T2. So if we calculate what is P2, we have already calculated as P2 We have already calculated P2 1837.9, 1837.9 into T3 1803.42 upon T2, that is already calculated 689.22. 689.22 will give the final value of P3. The final answer for P3 will be 4809.08. 4809.08 kilopascal. This is the maximum pressure in the cycle. I hope this is clear. 4809.08 kilopascal. Are you guys getting it? Bataiye, is this clear? This was question number 10 and let us move to question number 11. But before that, one more important announcement. At 5 p.m. just after this session, Abhinav Negi sir will be live on YouTube to discuss SMD and BMD for half an hour, 5 to 5:30, and then there will be a small quiz for half an hour. It is the civil versus mechanical war, means the civil and mechanical both students will be there in the session, and then the second part of the session will be on app to have the quiz, and the top performers will get the surprise gift hamper. So do join this session and enjoy the beauty. And tomorrow I will be there for the same series at 5 p.m. We will discuss the Bernoulli equation, and from 5:30 to 6 we will be having the quiz, and based on your performance in the quiz you can get the gift voucher. All right, so let us move to the next one, question number 11. I will try to finish the question or the session by 5 p.m. So try to get me the answer. Which one of the following is intensive, which is independent of mass, which does not depend on the extent of the system? It is the density. Volume depends on mass. Energy, specific energy is intensive, but energy is extensive. Half mv square, mgz. It depends on mass, extent of the system. So B is the answer. This was asked in 2022. Let us move to the next one. This was asked in 2022. Question number 12. In a vapor compression refrigeration cycle, the refrigerant enters the compressor. Let me draw a VC cycle on TS diagram. In a vapor compression refrigeration cycle, refrigerant enters the compressor in a saturated vapor state. It means 0.1 is saturated vapor at evaporator pressure with specific enthalpy equal to 250. This is H1. This is 0.1. This is saturated. So it is entering like this. This is compression. The exit of the compressor is superated at condenser pressure with the specific enthalpy equal to 300. This is H2. 0.2 is here. This at the condenser pressure. At the condenser exit, the refrigerant is throttled. So then there is a condensation of the refrigerant taking place like this. This is 0.3. This is condenser. Heat is rejected, that is Q1. This is the condenser pressure. At the condenser exit 0.3, the refrigerant is throttled. This is isenthalpic to the evaporator pressure. This is 4 to the evaporator pressure like this. This is evaporator. Heat is supplied like this. This is the VC cycle. The coefficient of performance of the cycle is 3. So do you agree this is work input? 1 to 2 is isentropic compression. So there is a compression work WC. And Q2 is the heat rejected from the heat taken out from the storage space. That is how it works. COP of the cycle is 3. The specific enthalpy of the saturated liquid at the evaporator pressure here. This value HF is given as specific enthalpy of saturated liquid at evaporator pressure is 50 kilojoule per kg. Then the dryness fraction of the refrigerant at the entry to the evaporator is means 0.4. The question is to find out X4. Do you understand it or not? Do you guys understand the question or not? We need to find out H at X4. First of all, COP. What is COP? That is equal to desired output, that is Q2 upon WC. Isn't it? Q2 upon WC. And what is Q2? Q2 is equal to H1 minus H4 upon WC is H2 minus H1. What is COP? That is equal to 3. COP is 3 is equal to H1 minus H4. H1 minus H4. H1 is given as 250 and H4 is unknown. 250 minus H4 divided by H2 minus H1, both are given 300. H2 minus H1, 300 minus 250. Isn't it? Can you find out the value of H4? So if you do the calculation, H4 will come out to be 100 kilojoule per kg. Are you getting H4 as 100 kilojoule per kg? So that can be written as HF plus X4 into Hg minus HF. And what is Hg? That is equal to H1. So that is equal to HF is given as 50 plus X4 into Hg, that is H1, that is 250 minus HF, that is 50. So if you equate these expression, then you will get X4. Then you will get X4. 0.25 will be the dryness fraction of the refrigerant at the entry to the 0.25. B is the correct answer. B will be the answer, right? The next question, question number 13. This was asked in 2022. Consider 1 kg of an ideal gas, mass is 1 kg. At 1 bar, pressure is 1 bar. 300 Kelvin, that is the temperature. Contained in a rigid means volume is constant, and perfectly insulated means there is no heat transfer. The specific heat of the gas at constant volume is given. A stirrer performs 225 kilojoule of work on the gas. So the work input is equal to 225 kilojoule. Or we can say work is done on the system, so it will be taken as negative. It will be taken as negative. Assume that the container does not participate in the thermodynamic interaction. The final pressure of the gas is. So how to find out the final pressure? Can we say from the first law of thermodynamics, can we say Q is equal to W total plus delta U? Q is equal to 0. So delta U is equal to minus W total. What is the total work? That is minus W due to stirrer plus integration of PdV, that will be 0. Integration of PdV will be 0 because volume is constant. So delta U, that is M into CV into T2 minus T1 is equal to minus 225. M is equal to 1. CV is given as 750 joule. It is in joule. So it is 0.75 into T2 minus T1 is 300 is equal to minus 225. Isn't it? It will not be minus 225, it will be plus. Why it will be plus? Because Ws is negative. Are you getting it? So we can easily find out the value of T2. We can find out the value of T2. What is the value of T2? T2 should come out to be 600 Kelvin. Once we get T2, the process 1 to 2 is constant volume process. As the process 1 to 2 is constant volume process, 1 to 2 is constant volume. So we can say pressure is directly proportional to temperature. So P2 by P1 is equal to T2 by T1. What is T2 by T1? 600 by 300, that is 2. So P2 is twice of P1. So P2 will become 2 bar. P2 will become 2 bar. Isn't it? The value of P2 will become 2 bar. There is a scholarship test on 18th of June, 12 p.m. You should register yourself for the scholarship test also. Based on your performance in the scholarship, you will be able to get the discounts in our various courses. If you have not joined and if you are planning to have your preparation in better way, or if you want to have your preparation more result oriented, then you should join the courses to get the guidance for clearing the examination. The link for registering yourself is already there in the description box. This is beautiful question. This is beautiful question. Let me give it as an assignment to you. The derivation I have already done in the previous class. If you have any doubt, you just let me know. This is for derivation for unsteady state flow process. Yesterday in the previous class, yesterday's class, we have done the derivation steady flow, unsteady flow process. For the unsteady flow process, mass conservation is mass entering minus mass leaving is equal to change in mass in control volume, and the energy conservation says energy entering minus energy leaving is equal to change in energy in the control volume. The question will be solved by using these two. Now the problem here is that the heat transfer is not zero. If the heat transfer would have been zero, if Q, direct result is if Q is equal to W is equal to 0, then T2 would have been gamma times of Ti. But because here Q is not 0, so T2 is not gamma times of Ti. So you need to find out the value. Shall I share the answer? The answer should be 387. The answer should be 387. 387 Kelvin. If you have any doubt, you can always write me or you can talk to me through the mail ID. Let us move to the next or the last question for the session. This is our last question. Question number 15 is at a steady state 500 kilogram per second. That is the mass flow rate. It is the steady state. It means mass flow rate remains constant. Steam enters a turbine with specific enthalpy equal to 3500. That is, let me call it as H1. And its specific entropy, that is S1. It expands reversibly in the turbine to the condenser pressure. Okay. It is isentropic. Is it isentropic? No, there is a change in entropy. So S1 expands reversibly, reversible expansion in the turbine to the condenser pressure. Heat loss occurs reversibly in the turbine at a temperature of 500 Kelvin. That is T. 500 Kelvin. If the exit specific enthalpy, that is H2, and this is S2. What is the work output of the turbine in megawatt? So if we write a steady flow energy equation, what is the steady flow energy equation? H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. Isn't it? So work need to be calculated. GZ1 is equal to GZ2, C1 square is equal to C2 square. There is no change in potential energy and kinetic energy. And because there is a change in entropy, so it is due to the change in entropy is because of the heat transfer, isn't it? The change in entropy is due to the heat transfer because it is reversible process. So can we say H1 plus T naught into delta S? Q is equal to T naught, Q reversible is equal to T naught into delta S, or we can say delta S for irreversible process is equal to del Q by T, isn't it? So T naught into delta S is equal to H2 plus W. So can you find it out? H1 is given as 3500 plus T naught is 500, and what is delta S? That is 6.5 minus 6.3 is equal to H2. All are in kilojoule. H2 is 2500 plus W. So you will get the value of W in kilojoule per kg. And if you want to find out in kilowatt or megawatt, then you need to multiply it by mass flow rate. So W is equal to mass flow rate into W. So in megawatt, your answer should be 450 megawatt. Your answer should be 450. Can you get me the answer for small w? What is the value of small w? 6.5 minus 6.3. 0.2. 500 into 0.2. 100 into 3500, 3600 minus 2500. Minus 2500. So W is equal to 1100. You will get W is equal to 1100 kilojoule per kg. So if you multiply with mass flow rate, what is the mass flow rate? That is 500 into 1100. So you will get it 55,550,000. That is kilowatt. In megawatt 550. Is it 550? ये क्या हुआ? Are you getting 1100 or not? W. $450 मेगावाट कैसे आ रहा है? मेरा तो आया नहीं. स्मॉल W is 1100 फिर. अच्छा, okay. Heat loss occurs, so it should have been subtracted, isn't it? It should have been subtracted. That is the catch. Yes, heat loss. It is the heat loss. Heat loss. So it should have been subtracted. Minus. So the value could have been 900, isn't it? Is it 900? So if you multiply with 900, then you will get 450 megawatt. So that completes our discussion for this. So the answer will be 450 megawatt. So that is all from my side, guys. And at 7 p.m. I will be coming live on the app, free app class, for discussing the previous year questions from the thermal engineering for ISRO exam. Right? Do join me today at 7 p.m. What is the date today? Today is 14th. At 7 p.m. we will have the question practice or question discussion for the ISRO exam. All right. So that is all from my side. Thank you for joining in, and do not forget to like and share this session to all your friends. See you in the next session. Till then, enjoy, take care, have a good day and a great career ahead. Jai Hind.